Everyone, thank you for joining us once again for our recurring bi-monthly webinar series. Today we're covering Creo Simulation for beginners. Please make sure you look at our website and check on future topics. You can find them ETRAGE, ETRAGE.com under the Events tab. You can also find a link on the upper right-hand corner of that site to our YouTube channel, where we have all of our past recordings available. And today's presentation will also be there, usually within 24 hours. A few housekeeping items. All of our attendees are muted. We would really appreciate all the questions you can think of during the presentation. There's an icon for Q&A in the upper left-hand corner of the interface. That's where you can submit all of your questions. Today's agenda, after my short welcome and introduction slides, we'll hand things off to Shei to cover all basic topics around Creo Simulate and drawing a few distinctions between the few options in PTC's larger suite of simulation tools. And of course, we'll wrap up with FAQs. Myself, Scott Rich, I have been in the industry for about a decade. I mostly work with customers to help them automate PLM processes, but that often involves simulation data and the need to share simulation analysis across different stakeholders well beyond engineering. Shei is a real simulation talent. We're all going to be enjoying today's presentation. More than 12 years in this space. I have seen him do some of these things in his head just to make sure he understood the content correctly. A little bit about ETRAGE. We have been around for more than 20 years. We do an outstanding job helping customers identify gaps in infrastructure, extend PLM data across the enterprise, beyond engineering to operations, to procurement, to management, and especially to the shop floor and manufacturing. We provide a number of our own products that complement and help with Windchill adoption. We integrate a number of different systems with Windchill, and we provide a number of services, including cloud hosting, custom application development, upgrades, and apropos to today's topic, a full spectrum of training on a variety of PTC topics. A little bit about our customers. They are any number of companies, designers, manufacturers of any size. The most common things they share is the need to make data available, again, across all departments to all stakeholders, automate how that data can be shared, make sure it's always updated and correct and accurate with revision, and then integrate. When you have multiple systems that have to be in place, we can make all of them hum together. And with that, I'll hand things off to my coworker, Shei Shinbore. We're all going to enjoy this one.
So go ahead and talk through, the simulation solutions that we have in Creo. And what I'll do is I'll start off like Scott mentioned with, showing the breadth of the simulation solutions that we have in PTC Creo, and then I'll finally, do a deeper dive into Creo Simulate specifically, right? But also not just simulate. Also, I think I'll start with mechanism as well and show how you can pass results from one to the other, right? And so first off in here, whenever you talk about simulation in the PTC landscape, there's many different, words and solutions, right? Especially they've come out over the last 5 or 6 years or so, and it can get very confusing to even know well what is what and what does and which should I use in what scenario, right? And so I'll spend the first few minutes here kind of disambiguating that, right? The first one I'll highlight over here, if you looking on the slide, is Creo Simulation Live, right? Or CSL. And that usually shows up, in your Creo window in its own separate tab, right? In this case, a third tab called Live Simulation. And usually that is that can analyze 4 different kinds of physics, right? So structural, analyses, modal, thermal, and then fluids, right? And by fluids, I mean essentially a CFD analysis, whether it's internal CFD or external, right? And the goal with CSL is essentially very quick directional feedback of how you can tweak or change your design to improve any simulation performance results, right? And so the reason why the advantage of Creo Live Simulation is, number one, it's meshless, right? It does not require mesh at all. And it's incredibly quick and fast, right? But the goal is not to get you super high decimal point numbers with which you can send a man to the moon, right? The goal is you can get a very quick, result plot, right? And then if I change a dimension from 5 to 6 or 6 to 6.5, let your model regenerate, and then Creo, the CSL, will immediately rerun, right, with a new geometry, and then show you the new result plot, right? And so you can then kind of get a differential of, okay, am I improving my simulation results or making them worse, by making that geometry change, right? So very quick simulation-driven feedback, right, of how you can improve your design, right? That's the goal or the intent of Creo Simulation Live, right? So the next few we'll discuss, and in this case with Creo Live Simulation, all of the the commands for that product, right, are within this Live Simulation tab right over here. Next we'll talk about is going to be the items in the Applications tab, right, of your Creo interface. And in this case, I'll highlight a few of them. First is Creo Mechanism, right? And within this module, again, if you click on that, it's almost like a doorway or a portal that opens a completely new dashboard with a completely new set of buttons that you can and commands. And in Creo Mechanism, the goal there is to number one, create kinematic analyses, right, of your mechanisms, right, and then also dynamic analyses, right. So what do I mean by that? Well, I mean, number one, you could create an assembly of any mechanism you have with, complete with the joints and sliders and rotational joints, linear joints, complete with, motors, whether it's a servo motor or springs and dampers and things like that, all of which are, simulating real physical entities in mechanisms that you can design. And then the kinematics is where you can analyze the kinematic behavior of all those joints together, right? So, and when I say kinematic, what I mean is essentially position, velocity, acceleration of, a particular, body or point or joint, right, relative to other ones at whatever point in time, right? And then the dynamic analyses within that, Creo Mechanism is where you can add into that any force, any forces, I'll say, in the simulation. So by forces, what I mean is that's where you can add in any mass or the additional point masses, or just the raw, weight of the components themselves, again, via gravity and also the material density of the components you're simulating. You can also then add in there friction at any of the rotational or at any of the joint locations, right? And adding springs and dampers, and also any external forces as well, right? So in that case, you're forcing the mechanism. You could force it with, for example, a servo motor for kinematic analysis, right? But then you're trying to say, okay, well, what are the forces that are seen by the different components based on all the different, physical components that we have in the simulation, right? And that's what the dynamic analysis gives you, right? Next is going to be the Creo ANSYS simulation. And for that one, that's a newer product that's come out recently within the last few years. And that one, I believe, currently primarily does structural simulations only, right? But this is one of the products that PTC is heavily invested into, and so a lot of new functionality will usually be shown come into this particular product. And so you can look to this to have more physics that it can simulate in the future, right? But the advantage to this is that so first off, what is it, right? It's a high fidelity FEA software, right? That is built or modeled based off of ANSYS's workbench code. Right? And so what I mean by that is you can start any analysis within Creo ANSYS simulation, right? And any results you have or setup you have in here, you can export into ANSYS workbench, right, for further analysis and refinement. And so we have some customers that either use Creo ANSYS simulation to supplement their ANSYS workbench spend. So maybe they already have ANSYS workbench, and instead of purchasing more licenses of that to expand usage, maybe they get a few licenses of Creo ANSYS simulation, right, to handle some very basic or preliminary analyses. And where you need the full power of workbench, then you could export that analysis to to workbench and then use workbench license for those. And then next is going to be the Creo simulation, right, or Creo Simulate. Right? That is, again, high fidelity FEA software. This particular product has been native to PTC Creo for decades now. And this has been the primary simulation or FEA software that PTC has used, even pre the collaboration with ANSYS, right? Now this allows many different physics, primarily structural analyses, modal, and also thermal analyses as well, right? And another difference with Creo Simulate is that this uses a P element methodology to mesh and solve your models versus usually, traditionally speaking, the H methodology for traditional FEA solvers like ANSYS solutions, for example, right? And then finally, we're going to be talking about, and then the last one is going to be Creo flow analysis, I should say, right? And in that case, that's a full-fledged CFD analysis solution, right? So where you can simulate the impact of fluid flow, internal or external, on your design, complete with other physics like multi-phase, heat transfer, and many other physics in that as well, right? And so again, the benefit of all of these is that you can do much more thorough and detailed simulation and analysis studies, right, without having to leave your Creo environment, right, without having to export your model, save as a step or an IGES or any other neutral format, and then pull it into a different application, right? And then if you have any design changes, right, and you have to update your geometry and then save as a new step file or things like that, right? The goal is you have a ton of different physics and simulation options right within the Creo interface that you can use without having to step out into a separate software, right? So for this particular exercise, or webinar, I should say, we'll be focusing primarily on Creo Simulate, right? That's the topic we're going to focus on. But in order to do that, we'll also use some results from Creo Mechanism in order to push it into Simulate as well. Now, in this case, for Creo Simulate, what we'll do here is, I'll start from Creo Mechanism, right? I'll run a mechanism analysis of this particular model, and this is a crankshaft assembly, right? A six-cylinder crankshaft or six-cylinder engine, and we'll run the analysis in mechanism, right? And then I'll take those forces in mechanism, export them to a particular part, and then I'll tell Creo, hey, I want to go into Simulate, right? And now let's go simulate the forces that were created from mechanism and then simulate them on that part, right? Now, when those forces are applied, this is kind of what they look like, right? So this is a particular component we'll be analyzing. It's a connecting rod, right? And you can apply those forces, again, based off of the inputs and the results from mechanism. And then finally, with Creo, with Simulate, you can also store the results in Windshield. That's the meaning of this, bulk results option over here. So essentially, for any design studies you have, right, once you run them, you have the option to store those results in Windshield, right? So that way, for any future case where if you ever get audited or things like that, and you want to have a record of, okay, the simulation results you had for a particular product at a particular point in time, what does that look like? You can always, view those results, from Windchill, right? And Windchill will download those results back into your Creo environment, and then you can view them within Creo, right? The important thing to note if you use this option is, number one, you do want to use a unique name, because again, that's a characteristic of Windchill, and that it enforces, file uniqueness, right? And so the default analysis name being analysis 1 in Creo Simulate wouldn't fly if everyone saves analyses, call analysis 1, and all want to check it into Windchill, right? It will throw up an error at some point. The other thing to note is that whenever you vault these results, not only will it store the results themselves, it also stores the model files that were used to create those results as well, right? And so if in fact you ever want to, again, do an audit in the future and you want to see, okay, well, what model did I use when I ran the simulation to get these particular result sets, right? It's also possible to go and view that as well, right, as part of this. So all that being said, this would be valuable in a company where, say, for example, you have very strict regulatory requirements, right? So call it, for example, medical device, industry, for example, right? Where you could be, audited by the FDA, for example, right? And you have to have very strict records of your design data for all the different parts and all the different variants, right? Of your models, right? This could be a way to say, okay, you know what? Let's store this data within Windchill, so that way it's not on individual engineers' computers, right? Or it's not on a shared drive somewhere where there's not the protection of the data integrity that Windchill provides, right? And then the other thing to note with this as well is that you would not want to vault your results if you're doing a lot of preliminary analyses, right? So and that's one of the other things with simulation is you could do 10, 20, 30 different preliminary or what if analyses to test out different variations, right? But once you finalize your design and you run one last final analysis, which again proves that maybe your design is actually good, right? That is what you would likely want to vault, right? Because otherwise you would just clutter Windchill with storing 20 different preliminary analyses, 19 of which were never intended to be the final product to begin with, right? Okay, and the way it looks like in Windchill, right, is going to be you'll notice the first two items over here within the Windchill workspace, right, are the test 2 MRS, test 1 MRS, right? Those are what the vaulted results look like within Windchill, and that's how you're able to see, right, that the results that are in Windchill, and you can then open them from within Windchill, within your workspace, as you can see here, right? And I'll show an example of that in the demo as well. So at this point, we'll go ahead and pause here and pull up Creo and then show a live demonstration of what I'm talking about. So. So in this case, I'll have this model. I'll go and open this, right? And like I mentioned, there's Creo Live Simulation, right? Which is not what we're going to be using today. I'll go into Applications. I'll start off in Mechanism. And in Mechanism, the UI changes, and now I see a whole different set of options for me to use, right? Again, it would take much longer than I can show in this webinar to offer all the different elements that you can define within Creo Mechanism, right? The important thing I'll just show here is in this case, for this particular design, there's a servo motor over here, right? That's controlling the rotation of this crankshaft, right? And that then moves all the joints for the connecting rod and also the pistons as well, right? So in this case, what I want to do is I want to go and create an analysis to figure out the forces, right? So I'll come over here for mechanism analysis, and I'll say I'm going to go define a dynamic analysis. Right? For the motors, servo motor 3 is the one that is currently active in this model, so I'll keep that one from start to end. And then for external loads, this is where I can specify if I want to enable gravity within this model. Right? And I also want to enable friction within the motion joints, right, for each and every one of these components over here. Right? I can hit run, and then not only does it just run or show the simulation, it also stores the analysis data, right, as well. Go ahead and click OK. And now the key step over here is I can now come under analysis and say I want to use in simulation. This essentially means use in Creo Simulate. That's what that functionally means. And I can come over here and specify, okay, well, what rigid body am I going to export the results for, and also what component. In this case, it's this connecting rod over here. And then I can tell it, I can ask it, hey, give me the result, right, at a particular time, right? Or at the start or at the end, or I can say the max for all loads, right? So in this case, this will give me the resulting load set for this particular component where the magnitude is a maximum, right, at any time period. Right? Now in this case, what I'm interested in simulating are going to be the forces that this connecting rod is experiencing, right? And so I'll deselect everything just to pick the forces, and I'll click OK, and that's that. Now I can also then go open my connecting rod. Let's save that. Now within this connecting rod, I'll go into Creo Simulate, right? And under loads, I can select, I want to have a mechanism load, right? And you'll notice over here, it sees the mechanism load set 1, the two forces that I had selected. Right? So all I have to do is click OK, and it imports those loads. Now you'll notice those loads come in at a point, right? So essentially it calculates them and has the resultant point, right, at which those loads are acting, right? It doesn't know the surface upon which to apply those loads. This is where I have to go tell it that, right? So now this is where I can pick on this force over here and say, hey, that load at the point with the magnitudes and that you have and the directions, apply that on this surface over here. And then likewise for this over here as well. And the other thing you'll notice about this is because this point is offset a little bit from the surface it's been applied on, there's going to be a kind of a moment load. And that moment is also captured as well, right? So if I, for example, edit the definition here and I go preview the load as it's been applied, you'll notice the preview arrows show kind of a twisting, right, or bending, right, that's occurring, right, as the load is applied. And all of that, again, it's something that Creo Simulate will take into account as a result of that. Next, I'm going to assign a material to this. And in this case, again, for purposes of a quick webinar, I'll just use steel. But again, you can always define your material properties and edit them to specify any different, and then you can change any of these values for your material properties to more accurately simulate the actual materials that you are using for your design processes, right? And then finally, I'll go and create a static analysis and this connecting rod. And finally, I'll inertia relief and click OK. And inertia relief, we only use that because I don't have any constraints defined in this case. Okay. Go ahead and save, and I can run that. Now, one of the advantages of the Creo Simulate engine or methodology of running, right, is maybe particularly compared to something like probably a H solver, is the fact that you'll notice in this case with Creo Simulate, for the same basic mesh that it has, right, it runs multiple solution sets, right? So in this case, it has there's pass 1 in this particular example where it calculates the solution at a certain complexity level. In this case, a polynomial order of 3, and then it says, okay, based on what I know, I need to increase the polynomial order to probably solve this a little bit better. So it goes up to p order of 4, and then runs us another pass at this, right? And so, again, this is one of the things that makes it more easier to use, is the fact that for the same mesh, for the same geometry, for the same analysis, Creo Simulate can run this, and iterate 3, 4, 5, 6, 7, 8 times, right? Which saves the user the trouble of having to always, refine a mesh, rerun, compare the differences. If there's a big difference, go refine the mesh again and rerun, right? Which is a typical workflow that you would normally do in an FEA analysis study. Right? So, key thing over here is I can now go over here under run, and if I want to store these results, if these are my final results, right, best and final, I can go ahead and vault these results, store them in Windchill, right? And you'll notice at the bottom left corner it says, the result set, .mrs, its vaulting has succeeded, right? That's all I would need to do from here. Right? Now I can go into the workspace, for example, right? And you'll notice over here that connecting rod, .mrs is a new item. Right? I can check this in to Windchill, right? And I can also view this in Creo, and say let's open in Creo, right? And it will then pull out the result window for me in Simulate, with which I can now specify. For example, I want to show a deformed model, overlay the undeformed. I also want to show the loads, and say, okay, yeah, let's do that, right? And so essentially, I that like so. So yeah, so what this is saying is, the black wireframe highlight is the undeformed model, right? And when the forces are applied with the compressive force from the top, right, and then kind of the bending, twisting force, kind of, bending and twisting rotate moment force, which is kind of counterclockwise down at the bottom over here, right? This is the deformed shape that you would expect the model to have, right? And you can now see areas where, for example, the stress is highest, right? And then ultimately you would compare this with your allowable, stress limits and see, okay, well, is this over that? And if so, what, can I do to mitigate that, right? And the other critical thing to note, I'll mention as well, is by default, Creo Simulate within this results window scales the deformation to 10% of the model size, right? And so I say all that to say the connecting rod in reality is not flexing by this much, right? By almost the entire width of the connecting rod, right? This deformation is exaggerated and scaled, right, for effect, right? So you can more easily see what's going on, right? And so that's one of the first questions I get is people run a simulation and they say, "Oh my goodness, this is so bad." And I'm like, no, it's your connecting rod is not going to bend that much. If it does in reality, something else is going on. Right? But again, that kind of shows, the end-to-end solution set from, taking a solution or a simulation from Creo mechanism, passing that on to the Simulate, and then running a whole slew of analyses on that as well. Right. So why does this matter, right? Ultimately, well, it's the fact that number one, right, you can accelerate your time to market, right? If you can have both your design package and your simulation package all in one environment, all in one screen, in one UI, right? It's the fact that you have to spend less time translating files back and forth from one software to another, right? And if loading changes, if geometry changes, then that's a new file you have to save out and then export and then resimulate, right? And then set up in the new software, right? It's the fact that, again, you're increasing you're making life easier for your employees, right? Without having to figure out and battle with multiple softwares that you have to use at a certain time, right? And all in the service of designing better products, right? Ultimately, if you're able to simulate the performance ahead of time, right, that could eliminate, or I guess I should say, reduce the number of the amount of physical testing that's needed in order to fully validate a design, right? And so, all that being said, we'll bring it over to questions and answers. I will. We'll have, I'll bring Scott back in, and Scott will, talk through some of these, FAQs, and then any other, audience questions that may have come in as well, right?
Thank you very much, Shei. I know you have a couple of questions there, and I've filtered a few that have been sent to me. First question, is there a limit on the number of surfaces your part can have with Creo Simulate?
Great question. And the answer to this is no. There's no limit with full Creo Simulate. With Creo Simulation, with Creo Simulate Lite, LITE, which is a very limited set of product that was available way back when. The limit was 200 surfaces, right? Irrespective of part or assembly or anything else, 200 surfaces, right? And you didn't have to count. As soon as you went into Simulation Lite, it would just kick you out and say, hey, you have more than 200, right? But I believe recently, as of I believe Creo Simulate is included with almost every base seat of PTC Creo nowadays, and so you should be able to take advantage of just the regular Creo Simulate without the limit of the surfaces on any of your models.
On those licensing specifics, I can speak to some of that. PTC removed that 200 surface limit for structural simulation, so all Creo seats now on subscription have that full structural simulation capability, but not the thermal and the modal. Second question, is there a limit on the number of analyses that can be run with Creo Simulate?
No. Again, to that answer, no, there's no limit. You could run, 2, 5, 100, however much you need to get to a level of confidence with your simulation results. Right? Yeah, there's no limit at all.
Next question, can Creo Simulate analyze an assembly or only an individual part?
Yeah, good question. Simulate can analyze assemblies, right? Not just individual parts. With assemblies, you will have to define and tell Simulate how it should handle the connections between the parts. Right? And so, for example, between a piston pin and the piston, right? Are they welded together so that way they're fixed and there's no relative motion between them? Things like that. And so, yes, as long as you define those relationships between the parts, yes, Simulate can analyze them very easily.
Shei, your audio might be failing just a little bit. Make sure you're close to the microphone. Related follow-up question on that one. How about non-linear simulations?
So Creo Simulate can analyze a lot of non-linear physics. And it's more specific. It depends on what being simulated that's non-linear. But if you talk about, for example, large deformation analyses, or if you talk about analyses where there's some plasticity, right, where it's the metal is being deformed, right, beyond its elastic limit. Or if you talk about things where there's hyperelasticity, right? So if you're trying to simulate things like rubber, for example, yeah, all of those are things that Simulate can handle, very easily, quite well, right? So yeah, and again, and if you need help with knowing, okay, what nonlinear physics can simulate, better, those are conversations that we can have with you to see, well, what are you trying to solve, and we can see how we can recommend, how you can use Simulate to solve those, right? Nonlinear.
Another question just in from the audience. What are the node and mesh limits for Simulate as well as Simulate Lite?
Great question. Node and mesh limits. There are no node and mesh limits for either software, Simulate or the Lite, quote unquote, option. If you had Simulate Lite, even though the limit was 200 surfaces or less, it does not matter if the mesh created from those 200 surfaces ends up being, 10 million, elements or nodes or whatever it is, or the 100 million. It doesn't care how many elements resulting from the surface limit, right? And the same thing with full-on Simulate, right? Simulate has no limit on node or mesh requirements, right? The only thing to be aware of is that the bigger the mesh, usually that results from a bigger or more detailed model, and usually that could influence the amount of RAM that you compute that Simulate will need to solve the solution in a timely manner, I should say, right? And so if you don't have enough RAM to store the big enough mesh, if essentially Simulate will start paging between RAM and hard disk, right? And it'll still eventually solve. It'll just take a much longer time, right? It'll slow down your solution time, right? And so, and again, that's where we can get into, making sure your computing specs are adequately sized to handle the size of the geometry that you're trying to simulate, right? But again, there's no hard-coded limit set in the software for mesh or node counts.
Follow-up question of my own on that, talking about RAM requirements and processing speed. Creo Simulate, far less hardware requirements or horsepower needed to compare to something like a CFD tool, correct?
Generally speaking, yes. Yes. Yeah, and that's just more so because, with Simulate, if you're solving, an FEA analysis, you typically, generally speaking, use, a smaller mesh than if you're doing a CFD analysis, right? And the mesh and RAM usage are very highly correlated, right? So the bigger the mesh, the more RAM you're more than likely using, right? And so, yes, CFD usually you use a much bigger mesh than FEA. Yeah.
Very good, thank you. Next, can Creo Simulate calculate the resonant and natural frequencies?
Yes, that will be a modal analysis, right? But yes, Simulate can handle all of that, yeah, just fine, yeah, even in modal analysis.
Next, can I use this tool to define moment loads?
Yes, yeah, correct. Yes, yeah, Creo Simulate can handle moment loads just fine. Even in the example where I showed you, where the resulting load will impact the moment on the part, and yes, Simulate can handle those definitions just fine as well.
We have a question from the audience. Do we offer Creo Simulate training? And I'll add on to that. What does the standard Creo Simulate training look like in terms of time required or days required?
Okay, good question. Yeah, so we do offer training on Simulate. It's usually, I think it's 4 or 5 day class where we go through some standard material, right? And we could also, and again, in addition to that, we also offer some mentoring as well, right? And so oftentimes we've had customers find value in yes, taking the standard class, but also maybe, have a, a half a day or a full day, open session at the end where it's kind of like a mentoring where they get to bring one of their parts, right, to the training, and that becomes the focus of discussion in terms of, okay, how they can set this up, how they can set up the constraints and the forces and the loads and analyze this in a way where you're trying to best accurately represent what's going on with the loading for the part, right? And how to then interpret the results that come out of that, and how to handle any simulation setup, questions that may arise as well, right? And so all of that is things that we can handle, training plus, and also mentoring simulation wise.
Very good. We're down to the last two questions, unless some last minute things come through the Q&A portal. So please submit those if you still have something you have not asked. Comment and question. I manufacture a number of components. Most use metals, but some parts require very uncommon materials. How can I use this to get good results for new, unique materials? For example, plastics, carbon fiber, and developmental metal alloys.
Okay, so plastics, carbon fiber. So everything you mentioned there, plastics, Creo Simulate so I guess ultimately it depends on the kind of physics you're trying to simulate, but yeah, Simulate can solve for plastic materials, carbon fiber materials, right? Those are, you can define those within Simulate as well, and also metal alloys as well, right? All of those are things you can define material properties within Simulate and also solve for as well, right? The key thing usually is if you don't have the material data, right, that might be, you might have to send a sample of your model to an independent lab for testing, where they can characterize and give you the material data, right? And once you have that, you can then import that into Simulate and use that in the analyses just fine.
Very good. A couple last minute questions coming in through the portal here. For the Simulate training, back to that, which version of Creo Parametric would we need to have installed? And the follow-up, what are the characteristics of the computer that is needed?
For that, the version we have installed, ultimately, it depends on if you're doing it, well, whichever way you do it, whether it's on site, at your facility, or in center, at our facility, we generally use cloud VMs for running these classes, right? And so in terms of hardware or characteristics of a computer that's needed, that's handled on the cloud side, right? So we have VMs that are very high powered with GPU plus RAM plus hard drive space, right, to ensure that you can get the full usage of the simulation software without any performance limitations, right? And then in terms of the version, we just, generally speaking, we advise that you use the same version that you're currently using in your day-to-day at the company, right? So if you're on Creo 11, it makes no sense to run the training on Creo 9, right? So we will install and run the training on the same software version of Creo that you're currently using. So that way, again, there can be parity, and you can apply what you're learning as soon as training is completed.
And I'll add to the attendee who asked that question. We'll reach out to you if you have specific questions on computer specifications to run Simulate. Shay and I will happily give you some input on what kind of machine he uses to run these analyses. Another question from the Q&A portal. Is there a way to take an assembly and treat it as if it were a solid part, like a weldment made from mini parts?
Okay. Great question. Yeah. So yes, there is a way to do that, built within Simulate as well, where you can define with multiple parts together, right? You can define whether they should be fixed, like you said, like a weldment, right? Or if you want to define it such that the two components are not connected together, but there is a weld at a certain location between both components, right? And you want to show the weld as the location where they're connected. Again, vis-a-vis weldment, right? We can handle that as well, right? And so it just depends on how you want to handle the model definition. But either way, whether it's defining it through a weld or defining it through where the the part materials touch each other, right? All of that is something that we can handle. So that way, Simulate can run, again, an assembly of several parts, even hundreds of parts, as a single big physical body, right? And you can still get the stresses on them, right, as a result of that. And again, that's something that we can talk to you about. If you have any additional questions about that, you can always reach out to us and we can give you some guidance on that as well.
All right, and barring the last minute new question, this should be the last one. Can the results from Creo Simulate be viewed in higher end simulation packages from PTC, such as Creo Simulation Advanced and Creo ANSYS Simulation?
Great question. So for that, let me go back to the slides and pull out this over here. So Creo Simulate and Creo Simulation Advanced are both essentially twins, right? Or they're both one on top of the other, right? So the advanced simulation that PTC offers in Creo is just an add-on to regular Creo Simulate, right? They both have the same UI. They both have, it's just a different set of buttons that are exposed with the Creo Advanced Simulation, right? And so yes, any result you have or your setup in Creo Simulate will easily translate to Creo Advanced Simulation, right? Now, if we talk about Creo ANSYS Simulation, right? That I believe I believe it's the results will not directly transfer into Creo ANSYS Simulation, right? Because again, both softwares are solving these using two different solver methodologies, right? But I believe the setup of the model that you have in Creo Simulate, a lot of it can transfer into ANSYS simulation, right? Into Creo ANSYS simulation. So when I say setup, what I mean is any forces, constraints, loads you have, movements you have, right? A lot of those can transfer into Creo ANSYS simulation. And the reason I use the word can is because Creo ANSYS simulation is still being developed as a tool in terms of the breadth of capabilities that it can handle relative to Creo Simulate, right? And so there are some, for example, force or load definitions that it does not currently support, right? And so those kinds of things will not transfer, right? But for whatever it easily supports, if you have just a typical, force, for example, those will easily transfer from Simulate to Creo ANSYS simulation, and then you can run the analysis from a Creo ANSYS simulation, and it will spit out to you, a different set of results, right? Based off of the, ANSYS, solver methodology, right, that it's using. And again, that could be one way you could also then, do a check and a comparison to make sure that, both simulation results should be telling you something similar. They should be within the same ballpark, right? And that can give you a better level of confidence that you are actually simulating, the physics properly, right? And you're not having, one isn't telling you Mars and the other isn't telling you Venus, for example, right?
I think that is going to wrap up our Q&A. If you have any final slides, information to share, thank you again, everyone, for joining us. We look forward to seeing you in our next presentations. And hopefully some of you can join us from New Orleans at the PTC User Summit.